All right, so looking at our objectives for today, pretty straightforward. Just find the measure of an arc, find the measure of its length. So let's go ahead and define these fairly quickly. It says find the arc measure of an arc, find the arc length of an arc. That's a good question. What is an arc?
Rainbow.
Kind of. All an arc is a portion of a circle. All an arc is. And we look at arcs in two perspectives. We look at it from an angle point of view, meaning basically what is the angle formed by this arc. And then we also look at its length. What is the distance from the two endpoints of the arc? So when we look at this arc measure, our arc is this portion right in here. The arc measure is the measure of the central angle. So whatever this angle is, that's the arc measure. And again, guys, big concept here. Arc measure is an angle. Big, big, big concept. The arc measure is an angle. The arc length is the actual distance from point A to point B as you go along the circle. Now, how many degrees are in a circle? 360 degrees. What is circumference?
The whole circle. 2 pi.
2 pi. Good. What is it?
Distance
Distance around the circle. If I go from A and I go all the way around the circle back to A, it's 2 pi r, correct?
Yeah.
All right. So now this is a big concept. Suppose I have a circle, and I have a 240 degree angle. What is the arc?
120.
What is the measure of arc AB? Now notice how I write that out. What's the symbol for an arc? Curve. It looks like an arch. Okay, what's the measure of arc AB?
120.
No.
AC plus CB.
Arc AB is 240. The measure of arc ACB
Oh.
is 120. When it just remember when we had angles, you had that third, right? You could do angle ABC. You go from the point to the center to the point. It's very similar with arcs. Arc ACB tells you go from A to C, B. Now let me ask you this. If the measure of arc AB is 240 degrees, how much of the circle does that actually represent?
3/4.
2/3. 240 out of 360 is 2/3. Alright? 240 out of 360 represents 2/3 of my circle. Do we agree? Yeah. So then how much of my circumference would that arc represent? 2/3. So what we're looking at here is a ratios and proportions situation. The measure of the arc, you take the ratio of the arc measure over 360, that is going to be the same ratio as the arc length over the circumference. And you guys should have ran across that if you guys had watched the videos or had gone to the website. You talk about that very explicitly. You talk about where that formula comes from. So we end up with is this formula. We get measure over 360 is equal to arc length over 2 pi r. And what does the 2 pi r represent? The circumference. So that's our little formula we're going to use today.
Measure over 360 equals length over 2 pi r.
Yep. Measure over 360 is length over 2 pi r. Arc length. Alright, so here we go, guys. We're going to take some very basic steps here. On number 4, all I want you guys to do is tell me the measure of each arc. Alright, Bree. What is the measure of arc AB? Yes, Bree? No. Arc AB from A to B, 60 degrees. Okay, you guys remember, the measure of the arc is the same as its central angle. So Caitlin, what about VWX? I'm not sure where you're getting that, but I want you to follow this in perspective. It's V to W to X. So V to W to X. Alright, tell me what you're doing. Very good. So if we take 360 and subtract 15, 345 degrees. Good. Yes, Bree?
Now, how come hers was at 15?
No, it's the arc.
Oh, never mind.
VWX.
I had this other framework.
Alright, and Corbin, how about number 6 there?
You would take Jn, which is 180 minus 30 degrees,
Okay.
gives you the 150.
Now, why did you do 180 for JN?
It's a straight line.
Because it's a straight line. One thing I do want to point out to you guys here, the arc of the diameter is 180 degrees, okay? Which you would almost say is kind of straightforward. But you want to make sure that it's going through the origin, and that's really important. If it's going through the origin, it'll be 180. Those small details.